Okay, really quick, chapter 1-4 review. This is the part where we talk about sometimes, always, never equations and solving for variable equations. If we are adding the 1-2 to this section, you will have to study the properties, which can be found in 1-2 section of your Google Classroom. But we're going to go ahead and review 1-4. Oh, I forgot to clear these out. All right, so the first one, we're going to go ahead and solve for a variable. We're solving for the variable n, so I'm going to go ahead and highlight n. The goal is to make sure this is the only variable that you see. Everything else we can assume to just be a number. So that means I'm trying to get rid of 5c and -1/2 d. I'm going to go ahead and subtract 5c first, because I have to use subtraction and addition to get rid of stuff first. So I'm going to subtract 5c and I have -1/2 d times n. 3c minus 5c, those are like terms, we can subtract them, so we get -2c. To get rid of a fraction, I'm going to multiply by the reciprocal, so I'm going to multiply by -2 on this side, and multiply everything on this side by -2. This cancels, -2 times -1/2 is +1. So I have d times n equals -2 times -2 times c is just +4c. Now we're still just solving this for n, so how is it attached to n? We're going to divide by d. So since I can't divide those, I just have n equals 4c over d. The next one, we're solving for w. Now this one's a specific case because we have more than one w. We have a w here and we have a w here. Okay, what I like to tell students, remind them, is that if I had, okay, we'll just write this down here, 4x minus 3 equals 2x, how would we solve that? Well, I would subtract 4x from both sides to get them on the same side. That's exactly what we're going to do here. Okay, we're going to subtract 2dw from both sides. So I have -3 equals EW minus 2dw. I still have two w's, so I have to figure out a way to rewrite that to only have one w. So I'm going to go ahead and use the distributive property backwards. I'm going to put a w in the front, and whatever I have left here, which is just e minus 2d, put it inside. Now I only have one w, which was the goal. So I'm going to go ahead and divide by everything other than w, since this is attached by multiplication. So e minus 2d divided by e minus 2d. Cancels out over here, so I have -3 over e minus 2d equals w. All right, the next one. Once again, we have x's on both sides. Okay, these are the most difficult ones on the test. Okay, x's on both sides. The rest of them aren't this difficult. So I have to get them out of the parentheses, and I have to get them on the same side. Just like if I had 3 times 5x minus 2 equals 4 times 3x minus 6, or whatever, I would distribute and then combine like terms. I'd bring the x's to one side and take everything else to the other side. Same thing here. I'm going to distribute. Okay, so I have 5amx minus 3an equals anx minus 4a. Still have x's on both sides, so let's get them to the same side. You can go either way. I'm going to go ahead and subtract anx from both sides. Oops, anx cancels here, so I have 5amx minus 3an minus anx equals -4a. My x's are now on the same side, which is good, but we have to get everything else to the other side. So what doesn't have an x with it? The -3an. So we're going to add 3an to both sides. We can't actually add those, they're not like terms, so I just have 5amx minus anx equals -4a plus 3an. X's, we're still solving, we have two of them. Just like the problem before when we had two w's, we now have two x's, so I'm going to do the distributive property backwards. I also like to say I'm going to fish out an x and leave everything else in the pond. We took out the x's, so I have a 5am minus an equals -4a plus 3an. Now this is just attached by multiplication, so I'm just going to divide by everything that we left in the pond. I'm going to erase this so that you can type room. This cancels. I have x equals negative 4a plus 3an, all divided by 5am minus an. All right, we're solving this one for x. Anytime the variable you're solving for is in the denominator, multiply by the denominator. This x is in the denominator, so I'm going to multiply by the entire denominator, both sides. So I'm going to multiply both sides by x plus 5. X plus 5 is going to cancel, and I'm left with a minus b equals d times x plus 5. I'm going to distribute my d. So I have a minus b equals dx plus 5d. Subtract 5d to solve x. Remember, we're solving for x. If this was just a number, we just subtract it, which is exactly what we're doing. 5d, and nothing is a like term, so it's just a minus b minus 5d equals d times x. X is my variable. So how is d attached? It's attached by multiplication, so I'm going to divide by d. Divide everything on this side by d. So I have a minus b minus 5d divided by d equals x. And then you can leave it like that. You can simplify it, but that's fine. All right, solving for p. Okay, once again, we have p on both sides. We're just practicing this again. So get your p's on the same side. So I'm going to subtract kp from both sides. So I have 9p minus kp equals negative 7 times n. So now they're on the same side, so use a distributive property backwards. So I'm going to put p in the front, and then everything else that I left, so 9 minus k, gets stuck inside the pond. I fished out the p and left 9 minus k inside. If I were to distribute this, that's what I get. So I'm just doing the distributive property backwards. And then divide by 9 minus k, since it's attached by multiplication. So I have p equals negative 7n over 9 minus k. Solving for y. So I'm going to subtract, this is just a number. This is the only variable we're gonna use. So we're just have a number here. So I'm going to subtract 12x. This cancels. I'm left with negative 4y equals 20 minus 12x. And now, still solving for y, how is negative 4 attached? By multiplication. So I'm going to divide both sides by negative 4. So I have y equals, and I'm going to distribute this. So when I distribute this, this becomes 20 divided by negative 4, which is negative 5. And then I have negative 12 divided by negative 4, which is positive 3 with an x. All right, we're solving for w. Now, you have two options here. This one's already highlighted. Two options. You can distribute, or you can just solve it from where it's at. I'm just going to solve from where it's at. I'm going to divide by 2, since there's nothing attached to w. And that's going to cancel this out. So I have a over 2 equals L plus w. Still solving for w. And then subtract L. So I have a over 2 minus L equals w. You're just solving equations with the same rules, only there's more than one variable. Solving this one for x. So I'm going to add by b to get rid of subtraction and addition first. This is the variable I'm solving for. So I'm going to add b, get rid of subtraction and addition first. So I have 1/3 x equals y plus b. Then how do you get rid of a fraction? Well, you can divide by 1/3, but that would look inappropriate or incorrect technically. So I'm just going to multiply both sides by 3. Make sure you multiply the entire thing by 3. So I have x equals, got to change my color. So I have x equals, you can put 3y plus 3b, or you can just put 3 times y plus b. Either way, you can distribute or not distribute, whatever you choose. All right, so this is a sometimes, always, never question. So is this equation sometimes, always, or never true? Well, we have to solve it first for x to c. I'm going to go ahead and distribute my 5 so I can combine my x's. So I have 5x plus 15 minus 3x equals 2x plus 15. Like terms gives me 2x plus 15 equals 2x plus 15. If I subtract 2x from both sides here to get the x's on the same side, they both cancel, and I'm left with 15 equals 15. Which means these two sides are exactly the same. 2x plus 15 and 2x plus 15 are exactly the same. So any number I put in here for x is going to equal this side because it's the same equation. So this is always true. And this is a true statement, so that also makes it always true. All right, so solve for x. We talked about this just a little bit ago. We're solving this for x if the variable that you're solving for is in the denominator. If the variable you're solving for is in the denominator, multiply by the denominator. So I'm going to multiply both sides by 3x plus 7. So I have 3x plus 7 times n, and then that's just going to cancel. Okay, now I'm solving for x, so I have to get the x's on the same side. So I'm going to distribute my n so I can get the x out of the parenthesis. So I have 3nx plus 7n equals x. Subtract 3nx. So I have 7n equals x minus 3nx. Now my x's are once again here. Just be careful here because when you take it out, what's left? Well, there's an imaginary 1 in front of every single variable. 1 times x is just x. So I have x on the outside and it's 1 minus 3n left on the inside if you look. 1 minus 3n. And then divide by whatever's attached to your x, 1 minus 3n. This one cancels. So 7n over 1 minus 3n equals x. We're solving this one for y. We did one similar to this one a little bit ago. We were just solving for x, so I'm going to add b. So I have 1/2 y equals x plus b. How do you get rid of a fraction? Multiply by the reciprocal. Make sure you multiply the entire thing by 2. Cancels, so I'm left with y equals, you can distribute or not, doesn't matter as long as you have parentheses. 2x, or I'm sorry, I didn't distribute. So 2 times x plus b. Or it could be 2x plus 2b. Okay, solve for the variable. So we have x in the denominator and we have an x above the denominator. So in order to get it out of the denominator, we have to multiply by the denominator. We just talked about this. We're doing another one. There are 2 of these on the test. So I'm going to multiply by 17x minus 16 on both sides. I'm just going to write on top of that. Okay, this side cancels. This side I'm going to distribute. So I have 17xy minus 16y equals 8x minus 5. Okay, we've done a couple of these already, so we're using the same rules. We're getting the x's on the same side, everything else on the other. So get this one x over here, get that 16y over there. So I'm subtracting 8x. So I have 17xy minus 16y minus 8x equals negative 5. Now get this thing, something that these both have x's in them. There's an x here, an x here. Okay, now they're on the same side. We got them to this side. Get rid of everything that doesn't have an x in it. So add 16y. So I have 17xy minus 8x equals negative 5 plus 16y. Fish out your x. Okay, use the distributive property backwards. What do you have left inside? If I take out an x, I have a 17y minus 8. 17y minus 8. I took out the x's that were in there and put it in front. I use the distributive property backwards. Equals negative 5 plus 16y. And now divide by 17y minus 8. Cancels, so I have x equals negative 5 plus 16y over 17y minus 8. And that's it. Okay, the only thing that we didn't talk a lot about is always and sometimes, always, never, so I'll go over that really quick. Again, we did an always. When do we have a never? Okay, well, let me write a never and a sometimes equation. Okay, so the top one, really quick. 4x minus 2x minus 7 equals negative 3x plus 2 times, negative 3 times x plus 2 plus 5x. So let's just solve this equation. So 4x, combine like terms, 4x minus 2x is 2x minus 7 equals, distribute, negative 3x minus 6 plus 5x. Now I'm going to combine like terms on this side. So that gives me 2x. And I have 2x minus 7 equals 2x minus 6. So if I subtract 2x from both sides, I'm going to get negative 7 equals negative 6. Is that true? That is not true. Negative 7 does not equal negative 6. So this one is never true. This equation is never true. For this one, I'm going to distribute 3x minus 3 equals 4x plus 7x minus 35. And distribute both of those. Combine like terms, 4x plus 7x equals 11x. Subtract 3x from both sides to get them to the same side. So I have negative 3 equals 8x minus 35. Add 35. So I get 32 equals 8x. Divide by 8. So x equals 4. So this is sometimes true. This equation is only true when x equals 4. So we would say it's sometimes true. So if you get an answer that looks like this, it's sometimes. You get something that looks like this, it's never. And then the one before where you had 8 equals 8 or 10 equals 10, those are always true.